So this is the first lesson of chapter 10, and this is looking at special values for trig functions. So to begin with, we just did a quick review of some of the different ratios that we use. So sine theta is opposite over hypotenuse, cosine theta is adjacent over hypotenuse, and tan theta is opposite over adjacent. And a lot of people remember this from SOHCAHTOA. And SOHCAHTOA is a nonsense word, but it takes the first letters of this. So SOH, CAH, TOA to help remember those specific ratios. And also it goes in the same order. O over H, O becomes before H, A over H, A becomes before H, and so on. Now also there's other angles related, other ratios related as well. So tan, we also have cotangent, which is just the reciprocal. So in other words, it's adjacent over opposite. And annoyingly, the opposite of cosine is secant, which starts with an S, so some people often get that mixed up with sine. So instead of adjacent over hypotenuse, we have hypotenuse over adjacent. Even more annoyingly, the reciprocal of sine is actually cosecant, which even starts with cos, but actually it's the reciprocal of sine, and we normally abbreviate cosecant to CSC. So if we're doing cosecant theta, that's just going to be the reciprocal of this, so in other words, hypotenuse over opposite. So important you know all those ratios so you can actually make any of the calculations that you're asked to do later. So to find some of our special values, we're going to start with this equilateral triangle and then split it down the middle. So the angle gets bisected and also the side gets split in half as well. And radical 3 comes from Pythagoras, 2 squared minus 1 squared, all square rooted, gives us radical 3. And then you can fill in all the special values for 30 and 60 using the properties of the sides. So sine is opposite over hypotenuse, which I filled in here. Cosine is adjacent over hypotenuse. And tan is opposite over adjacent. And anytime we have the radical on the bottom, we're just going to go ahead and rationalize this. So 1 times radical 3 is radical 3. And radical 3 times radical 3 is 3. And that's what we have here. Now when we look at the 60 degree, then this becomes the opposite side and this becomes the adjacent side. But same idea, if we want to do sine 60, opposite over hypotenuse. If we want to do cosine 60, adjacent over hypotenuse. And if we want to do tan, then we do opposite over adjacent. And radical 3 over 1 is just simply radical 3. This is one of the triangles you'd be expected to learn because we're going to be using this triangle a lot when we work out some other special values later. Now this time I actually set up an isosceles triangle, side length 1, and then the missing side here is going to be radical 2, 1 squared plus 1 squared square rooted gives you radical 2. And I can do the same sort of thing. If I get rid of one of these 45s, then this becomes my opposite side, this becomes my adjacent side, and then this becomes my hypotenuse. And then I can start working out certain ratios. So sine is opposite over hypotenuse, 1 over radical 2, and rationalize. Cosine is adjacent over hypotenuse, and rationalize. And tan is opposite over adjacent, and 1 divided by 1 is 1. And the same thing, this triangle also needs to be learned. So 30, 45, and 60, all those angles can be calculated for later questions. Okay, so when we start looking at angles that are above 90 degrees and multiples of 30 and 60 and 45, then we need to start doing something slightly different. So CAesti is something we're going to use. I mean, you might want to pause the video at this point and actually copy down these 5 steps, and I'll talk about how you actually use those in answering questions. Now, CAesti, hopefully you saw in your previous class, A stands for all, S stands for sine, T stands for tan, and C stands for cosine. And it tells you when, as you can see here, when each ratio is positive. So every ratio is positive between 0 and 90. But between 90 and 180, only sine and the reciprocal function, in other words cosecant, are going to be positive. Now that also tells you some additional information because it'll tell you when things are negative. So if sine is positive, then that tells you that cosine and tan are supposed to be negative. And also their reciprocal functions must also be negative. Down here, if tan is positive, that tells you that sine and cosine must be negative. It also tells you that cotangent must be positive, and it also tells you that secant and cosecant must be negative. And we'll use those 5 steps to answer some questions now. So if we're working out tan 150, then we've got to remember that when we measure our angles, we're going to measure counterclockwise from the x-axis here. So we're going to go around 150 degrees, which leaves an additional angle here, and this is the angle that we're actually interested in. We want to know the angle it makes with the x-axis. So this would be 30 degrees, because together this would make 180 degrees. Now the 30-degree triangle is one that we had earlier, because this is our special values. So if we label the sides 1, 2 and radical 3, making sure they're in the correct place, then we can start to answer the question. So as we're doing tan here, we're going to do opposite divided by adjacent. So the opposite side is 1, and the adjacent side is radical 3. If we rationalize that, then we get radical 3 over 3. Now using CAesti, CAS, S tells you that only sine is positive. As this question isn't sine, that tells you the answer must be negative. So we go ahead and insert our negative sign at the end of the question. Now if we look at sine 225, there is a sort of shortcut for this. Any question that ends in 5, we know it's going to be a 45-degree angle, because that's one of our special values. So if we can around 0, 90, 180, then we need to go an additional 45 degrees to make 225. And then we can go ahead and draw our 45-degree triangle in. Remember, this was the Isoceles Triangle, so 1, 1, radical 2. As we're doing sine here, write down the appropriate ratio, opposite over hypotenuse. Substitute in the values, opposite is 1, hypotenuse is radical 2. Rationalize. And then using CAesti, this time only tan should be positive. And as we're doing sine, therefore the answer must be negative. And that's that question done. One more, cosine of negative 420. Now questions that are outside 0 to 360, what you can do is you can add on 360 to this. So that will give us cosine of negative 60. And we can add on also another 360 to give us 300. Now the reason we can add 360 on is 360 is a complete revolution, so that doesn't actually change where the angle is. Now, negative 60 actually means we go 60 degrees in the opposite direction, which would be as the picture shows here. Or we could go to 300 and go 90, 180, 270, go an additional 30 degrees to make 300, leaving 60 degrees here to make up the 360. So a couple of different ways you can draw that picture, but remember you must do the angle in relation to the x-axis. Then from the triangles that we drew earlier, radical 3 is opposite 60, 1 would be the other side, and hypotenuse is 2. So cosine is adjacent over hypotenuse, so our adjacent side is 1, our hypotenuse is 2, and using CAesti, this is C, so cosine is positive, so we leave our answer as positive 1/2. You can see I made a small mistake when typing that, so the answer should be 1/2.